Alright, so today I'm going to be building the Fox Tone Machine clone from General Guitar Gadgets. It's a pretty cool little octave fuzz that I think it was made in like the 70s. Its closure about that big or so. The enclosure was fuzzy. It had like velvet on it for some reason. This one's kind of a mod on it. It has a second foot switch, and I think the second foot switch kind of disables the octave effect of the fuzz, so it's a little more typical. And then you click the switch, and it gets pretty gnarly and nasty. But that's what we've got: 2 foot switches, 3 potentiometers. They're all B50K pots. Input-output jack. 9-volt jack, standoffs for the circuit board, a little bag of resistors, little bag of capacitors, little bag with some LEDs, some diodes, and 3 transistors in it. So I'm just going to get started. I usually do resistors first, just because they're small and they kind of tend to stay out of the way when you start putting bigger components on. Clean off my work surface here. It's got Arby's crumbs on it. And I'll pull up my little calculator for resistors. Basically, I just punch in the colors that are on there and it tells me what the value is. Most of them I kind of know by now, but sometimes I just need a little internet assistance. Get my helping hands here. Kind of get them set up to hold the board in a decent way. Like that. And that's when I can go and flip it. Is that a little better? I can actually see what I'm trying to do now. Zoom in just a bit. Is that in the frame? Yeah, that looks good. Alright, get my tools out. Normal stuff. Solder. Wire cutter. I use rosin core solder, which is just easy to work with, and it's pretty standard. What else do I need to have out? I think that'll do it. I'll pull out some other tools like a solder sucker just in case I mess up. Little picks and screwdrivers and pliers if I need them. Tweezers come in handy a lot. But for now we'll just start with this, and the rest of the tools are just kind of if I screw up really. So alright, just pick up a resistor. Here's our first guy. Its colors are brown, brown, black, purple, yellow, which I think is a 47K. Let's see. 4.7K. I was close. So, just gotta find a spot on the board where that goes. Looks like right there. And I bend the leads down so it looks kind of like that. If it wants to focus, y'all can see it. Slide it right on in. I bend the leads out a bit. Flip the board around. I'm gonna have to move the camera again. Yeah, alright. And then I just solder it. Resistors can go in any way they want, as long as they're in the right hole. They're pretty foolproof, really. Just like that. And the other leg. I just like to flow them again to make sure they actually go through. We have a resistor in. I just cut the little legs off. I usually save leads off the first couple of things I put in because they work really well if you have to, if there's a part that you need to put a jumper through, where instead of putting a part through two holes you just put a wire so it doesn't affect anything. And those make really good little jumpers. So there we go, one resistor in, one down, many to go. Let's see, this next one is brown, black, black, red, brown, which I think is a 10K. Yep, that's a 10K. Oh yeah, that looks a lot better, doesn't it? I'll try something here. How does that look? Can we zoom in even more? Oh yeah. All right. So we decided this was a 10K. Go ahead. Find a 10K hole. go ahead and flip it around. And solder them in place. Trim our leads nice and flat so they're out of the way. And if you have too long of leads, they kind of turn into little antennas. They just make your pedals that much noisier. And usually when you're DIYing pedals, they're already plenty noisy just because there's a lot of things that bigger manufacturers will do to make less noisy pedals that are hard to do when you're just working on a bench in your bedroom pretty much. But you know, there are steps that we can take to try and prevent some of that. Alright, so this next one, brown, black, black, brown, brown. It's not going to want to focus, is it? No, that's alright. Brown, black, black. Brown, brown, that's a 1K. Let's find a spot for a 1K, which is over in the corner here. And again, just gonna solder it. This is pretty much the whole process. The interesting stuff kind of comes later when we start actually wiring things together and trying to stuff all these parts into the enclosure, but I find this part to be the most relaxing because it's monotonous, but it's not boring by any means. Alright, 10K is in. I dropped a resistor. I do that a lot. They're tiny little things. Alright, yellow, purple, black, brown, brown, I think. Now that's going to be a 47K. That's another 4.7K. Where does that go? Right up here. Now when I'm doing a second resistor or third resistor that has the same value as some other ones, I will make sure they're all facing the same direction. So you can see on this one, maybe the yellow is on the top there. It goes yellow, purple, black, brown, brown. So up here I will just phase it the same way just because it looks better. It doesn't make any difference electrically or sonically, but it just looks better. And I like to at least try to make a good product, especially when I'm putting together kits that other people have made, because I like to do justice to the hard work that they put in so that guys like me can come along and play some of these pedals that are based on old circuits. And if I wanted to go buy a real Foxtone machine right now, I'd be looking into hundreds of dollars, and now I can build one for, I think this kit costs $60 or something. Pretty cheap and not too much of my time. And it's something I really enjoy doing. Alright, got another brown, brown, black, black, brown. Or brown, black, black, brown, brown, I guess. It's a 1K. That's the value it wants, so. Find another hole for a 1K. There's always a possibility there won't be one. They send extra parts quite a bit, so. I'm not seeing one, so we'll just hold off on that. We'll wait on that guy. Alright. That's not gonna focus, is it? This is yellow, purple, black, red, brown. Now this one finally is the 47K. Which there are quite a few of. So we'll put it in. I'm going to do yellow on top again, just because that's the way the 4.7s were, and it'll look better. Feed it through. And if I can, I'm going to find another one, because I see there's a hole right next to it. These two right here, right on top of my finger, are also 47K. So I'm going to dig out the other 47Ks and just do them all at once. So that way we're done, and it speed things up a little bit. What's this one? That's yellow, purple, black, orange, brown. That's going to be a whole different value. Have I already made a mistake? Nope. Right here. Actually, I just kind of noticed I actually have the whole board upside down, but doesn't really matter. Alright, so now we got 3 resistors to put in, and I'll just go left to right and top to bottom. 1, 2, 3, sometimes they don't want to go when you're working around a corner like that, but there we go. These are easy enough. Trim my leads. Try to trim my leads. This is a lot harder to do when you're filming and trying to make sure you're getting a good shot. But I like the challenge. I like tinkering with all this stuff and trying to set up cameras and microphones and all that. It's fun. It's a little stressful at times, especially when the post office won't give you your package, but it's all a part of the process, and that's what's most fun to me. Gotta stay vaping here. Alright. So here's another 4.7K. And I'm not sure where that one goes. It might not go anywhere. Doesn't look like it. We'll just move on. Alright. Brown, black, black, brown, brown, which should be a 1K. Yep, that's a 1K. We had a 1K earlier, didn't we? Let me just see here. Yeah, that one's a 1K. So we'll put these in the same direction. Just like that. And let's populate some other holes just so we're not here all day. Here we have a red, red, black, red, brown. That should be 22K. I'll check it before I put it in, but I'm pretty confident in that. Red, black, or brown. 22K. Alright. Solder it up. That lead was still a little hot. Burned me. That's okay. Alright. Trucking right along. I'm just gonna quick go ahead and pull up the diagram for this here. General Guitar Gadgets is nice enough to include a bunch of documentation for their sorry, I lost my train of thought. General Guitar Gadgets is nice enough to include a bunch of documentation that goes along with all their projects. So they have a bill of materials, which helps you identify parts if you don't know what is what. A schematic, so you can look at what the circuit actually looks like and how it works. And then also a part layout and wiring diagram. And I like using the parts layout just to make sure I'm putting everything in the right spot. And there's also some parts that aren't labeled with their values. Like here we have D1, which is a diode. And I don't know what diode goes there. I mean, I could probably figure it out because they only gave me 4 diodes and they're all the same. So I'd figure it out, but it's just a handy little tool to have. And sometimes if I can't find where a part like a resistor goes on the actual board, I will look at the diagram online and that will help me decide where to put it. So next one, we're looking at brown, red, black, black, brown, which should be a 12 or a 120? 120 ohm. That doesn't seem right. It's a pretty big value. It can happen though. No, that's not right. Sometimes these codes need to be kind of read backwards. So yeah, that's a 10K. We need a 10K. Where does a 10K go? Over here in the corner, hiding from me. But yeah, sometimes a resistor can throw you off because you read it one way and it has a certain value. If you read the colors a different way, you know, backwards, they'll have an entirely different value. And it's just important to think through it logically. Like I said, what did I say, like 110 or 120 ohm or whatever. That's a pretty big value resistor. And while they can appear on small pedals like this, it's not likely, especially not what kind of circuit this is. You know, there are some big ones though. Like there's usually going to be a 1 meg somewhere. Yeah, here's a 1.5 meg, which is a pretty large value resistor as well, but it doesn't show up all that often. We'll say that. Usually that has to do with power, making sure parts are getting the right power, especially if you're ever dealing with chips, integrated circuits, or op amps and stuff. They need to have pretty well controlled power so that you don't fry them and things like that. So a lot of times you need a higher value of resistor to make sure that doesn't happen, because that'd be bad, because some of these chips are really expensive. Like the chip that's in, let's see if I can pull it off and show you. chip that's in this guy. This right here, which is a pedal I made called the Henry Hill. It's a Rat clone, but it has an OP07 op amp in it. And those are pretty expensive parts. I think they're like $8 or $9 through Mouser, and they're usually pretty hard to find too. Usually you got to do a lot of digging through Mouser or DigiKey to really find them because they're just not really used anymore for anything except for guitar pedals. And there's not a ton of people building guitar pedals, so there's quite often a little bit of a challenge, or you got to know some people to really find out where to get those parts. Find my flashlight here. I'm having a hard time looking at the colors on this guy because they're kind of weird colors. There we go. That made it focus. Not enough light to see the colors though, and it looks like it is brown, orange, black, green, brown, which is kind of a weird color. It's like 150K. And that's gonna go, I saw that earlier, right here. Alright, that one's in. Oop. Throw the damn thing on the floor. I do that pretty often. I'm just gonna grab a drink of water quick. I'm not used to talking while I do this, I'm really not, but stay hydrated. I hope people will enjoy watching this. Hope someone at least stops by to hang out. Because I think it's really interesting, and I think there's stuff to be learned from this. Alright, brown, black, black, brown, brown, which we know is a 1K. I think we've done this already, but there's not a place for a 1K to go. Set that aside. What are we looking at here? We're looking at brown, orange, black, black, brown. See if it'll do it again. It should be 100. Oop, that's not 130. It's a 100K. Which goes right here. I'm just going to populate a bunch of spots here. And spin it around and solder them, just so this isn't 3 hours long. Brown, red, black, green, brown. That's gonna be 15K. There's a few 15K, aren't there? Here's one. Brown, black, black, orange, brown. That's 100K. Make sure to put this in the same way as this one, which is 100K. Let's put the other one in too while we're thinking about it. Wow. Trying to work around these arms is sometimes a pain in the ass, but it's definitely a lot easier than trying to work without them. Trying to hold a circuit board and solder it at the same time just doesn't work. There we go. We're getting down there. We only have a few more places to populate. Red, red, black, black, brown, which is a 22K ohm resistor, which I don't see. If there's one that I don't see right away, I'll just move it aside. Just kind of set it on the base of my little helping hands here. That way, if I get done and I see there's still resistor holes that need to be populated, I can just come back and see which ones are which, and it just helps me move along without staying caught up on one resistor. Alright, here's a 470K. There's another 470. I think we decided yellow goes on top. Get that in there. What else do we have? Looks like brown, black, black, orange, brown. That's 100K. Goes in there. grab my light again because I can't quite see this one. Brown, brown, black, green, brown. It's an 11 meg. That doesn't seem right. Here, that's a 1.5K. We had one of those earlier, didn't we? Yes, we did. Put them in the same way. Alright, here's another one with some funky colors. Brown, green, black, yellow, brown. That's a 1.5 meg. That's that big one we talked about. Let's go ahead and solder all these ones. And then we'll just do the last couple and we can move on to capacitors, which are ever so slightly more interesting than resistors, because resistors are pretty boring. And also sometimes the most time consuming, because you have to read all the codes, and a lot of times capacitors will just have their values written right on the front of them, so you don't have to. Oof! Something was hot. Ooh! That lead burnt me twice. Usually they cool down a lot faster than that, but I usually set my soldering iron pretty dang hot. Alright. Clip these little mofuckies off. Yeah, ouch, that was a pretty good little burn. It still kind of stings. And last one. Oh, alright, I'm gonna put some chapstick on. Spin back around. Here we have another brown, black, black, orange, brown. Which is 100K. 100K goes there. And what are we missing? Missing 147K. I think that's it for resistors. Looks like this is a 47K. It's yellow, purple, black, brown, brown. A 4.7K. Uh-oh. Did I put something in the wrong slot? I probably did. So 47K is yellow, purple, black, red, brown. So let's see which one is in the wrong spot. So that's a 47K. It's supposed to be a 4K7. So right there is where we goofed up. So I'm gonna go ahead and pull this 100K out. Just give us a little more room to work. Putting resistors in the wrong spot happens all the time. Just because colors can be confusing and things like that, so. How am I gonna film this? For me, the best way to take them out is to kind of put them upright. Like that. And then on one side, I'll heat up the solder. And I'll pull them out with something like this screwdriver. I just kind of stick it under there. Get a little bit of leverage. Usually resistors are easy to pull out and put back in the right spot. Grab a pliers here. And I'll just kind of pinch the other end of it. Heat the solder. And there we go. Came right out. And then I'll just kind of fix up the leads so they're kind of in the right shape. It's a little bit annoying having to solder them in place with kind of stumped off leads, but that's all right. I'll put it in the slot it's supposed to go into. Sorry, y'all can't see what I'm doing at all. There we go. And I'll just quick solder that one into place right there. Sometimes they like to kind of fall out when you solder them. So I will just give them a little push. I'll go ahead and reheat this lead here. Just flow some extra solder into it. A little extra doesn't hurt. There we go. It's like it never happened. And it actually left just enough for me to be able to trim it down a little bit. I really need to get some smaller wire cutters, but that's alright. That's alright. Okay. So now we can put this 100K back where it's supposed to go. Oh, I actually forgot an important step. So, not sure if y'all are going to be able to see this or not, but see, where will it focus? Alright. So, find what I'm looking for. Right there, that's where we just took out that one that was in the wrong spot. And you can see there's now solder filling up the holes. I usually will take a solder sucker and just clean those out. And that's easy enough. Sometimes it can be a pain, but go ahead and pull in another arm here to help me out. Make sure my solder sucker is clean. Sometimes they aren't. Usually mine aren't. Alright. And I'll just stick the little nozzle on the solder sucker over the spot that I need to clean out. Stick my soldering iron in, heat it up, and forget to charge the solder sucker. Not quite. Sometimes it takes another shot. Alright, that'll do. And this other one isn't too bad. I'll go ahead and clean it out too. There. Alright. That's all dealt with. We'll go ahead for realsies this time. Put this 100K into its slot. We'll also put in the 4.7K into the slot. It is meant to go. Looks like I didn't clean out that pad enough. Kind of make this difficult. I'm just gonna clean that out real quick from the other side. There we go. There. Fits like a glove. And then solder these last 4 little legs of the resistors, and then we'll be all done with resistors. I think. It's important to double check the board once you're done to make sure you have all the resistors in, because it's a real pain in the ass to go back and put one in, especially if you've started putting in any wiring, or if you've if working with any circuits. It's a real pain to work around sockets. But you know, it all can be done, but anything to save a headache. Alright, then I'll just kind of go around and clip any leads that look like they're a little too long. Sometimes I'll use this wire cutter, which is flat on the end. And that'll let me get just a little closer, but it's wider, so sometimes it's hard to get around components, get a good grip on things, but I hope y'all are having fun, because I sure am. This is lots of fun to me. This is exactly what I love to do, and everything more. Alright, looks like we're good to go on resistors. I don't see any unpopulated holes, really. So we'll move right along. We'll take a little break and drink some water again. Alright. So next I'll move on to capacitors. Now this kit comes with two different types of capacitors. We've got ones like this. These are called box film capacitors, and they're non-polarized, which means they can go in any way. There's no positive or negative. Whereas these ones, which are called electrolytic capacitors or aluminum electrolytic capacitors, they are polarized. And you can tell which side is positive and which side is negative because they will have a stripe on the side. I'll try and shine some light. So you can see right there, it turns to gold. That notates the negative side. And the negative side goes into... So here is where electrolytic cap would go. You see the square hole is marked with a positive, and then the other one isn't marked at all, it's a round hole. That's the negative terminal, and that's where that stripe's gonna go. But I usually do the box film, the non-polarized capacitors first. So sometimes these can be a little tricky because they'll say almost anything on the sides. These ones say 0.1, which makes me think they're 0.1 microfarad, which is how you measure capacitors. These ones on the top say 47NJ100. And that's a little confusing at first, but after you do it a couple times, you learn that that's a 0.47 microfarad. This says 1NK100 on the end. And I think that's a 0.1 microfarad, but we'll have to look that up because I don't know. And then this one says 3N3J100 on the end. I have no idea what that means, so that one we will have to look up. And sometimes the diagrams that General Guitar Gadgets sends you will tell you the values. Sometimes they don't. Like here, this just says 102, and same, it also says 102. I don't know what 102 means. I think that we will have to either look at a schematic or we will have to look at the bill of materials that General Guitar Gadgets sends. Just waiting for the page to load here on my laptop. let's look at the bill of materials and see what because usually what the bill of materials will say is like this port right here. This notates C2 capacitor 2, and the bill of materials will say this value of capacitor is C2. So, like my internet's mighty slow this morning, which is not abnormal. So we'll wait. Says the page is unresponsive. Hi, Toledo. Hey, big guy. Let's zoom out and talk to Toledo. Come here, big guy. Oh, no. Don't you run away. I'm picking you up. Such a fluffy boy. He doesn't like being held, so this is not going to last. But he's not squirming yet, so maybe he'll stay for a while. Sometimes he likes to hang out. He kind of stinks, honestly. He kind of smells like poopy. Alright, I think he's ready to get down. So we'll put Toledo down. Now I am covered in fur. Stand up and stretch. Reposition my chair a little bit, maybe. Go ahead and bump the mic stand. I need to get a mic stand for my desk. One that will fit a little better if I'm going to continue to do this. Oh, I think my VPN might have kicked back in. That's why. VPNs are nice because they keep you a little safer on the internet, but it can also be a pain in the ass when you want to do anything, especially anything that requires a decent amount of loading. So let's see if we can figure some stuff out here. Alright, I'm just gonna Google the value of these red ones here, just because I'm having a hard time. Alright. Alright, so these red ones are 0.1 microfarad. 0.1 microfarad will go into C1 and C3. Go ahead and pull out our parts layout again. C1. Oh, we know C3 is here, so we could stick that in. And bend our leads out. And then C3 C3, C1. I got them all mixed up. I have to make sure those are facing the same way. Not that it really matters with capacitors, but again, it just looks better. Gets a prettier product, and I like to try and make my projects look as decent as possible. Let's maybe zoom in a little bit. There we go. Capacitors usually I like to solder a little faster than I would resistors, especially these metal film ones, or box film as they are, because the housings are made of plastic and I have melted them before. It's easy to melt them from the outside, but if you heat the leads up for too long, you can melt them from the inside. Doesn't happen a lot, but I've done it. And it's definitely a pain in the ass, because then your capacitor's probably kaput or it just looks bad. Alright. Oh, look at that. I accidentally unscrewed my alligator clip here. Alright. Alright, so this one says 47NJ. Because it says that, I know that it's gonna have a value of, yep, 0.047, which is C11, and C11 goes right here. So slide that guy in, bend the leads out. What else do we got? We have a 1NK100 and a 3N3J100. I think 1NK100. I've looked that up. Yep, that's a 0.001 microfarad. So that's going to go into C2, which is this one up here. And finally this guy. And I'll just Google him too. Just 3N3J100. Usually you can just Google that and it'll come up with it's a 3300 picofarad, which is a 0.0033 microfarad. And that goes into C10. C10 is gonna be right here, marked 332. Real quick, put these guys in. Sometimes easier said than done, because I get really shaky after doing this for a while. We've already been working for like an hour. Some people can put these together faster. I'm not really about speed. You know, if I were making my own, with the intention to sell them, I would definitely work a lot faster. And I could work a lot faster, but half the fun, not half the fun, all the fun is actually building these. You know, I don't always even use them after I built them. Like for example, I built this behemoth, this big guy, and I don't even use it. It doesn't even sound that good, but it was a lot of fun to build, because there's actually 4 separate circuit boards in here, and, you know, 3 big switches. There's a lot of wiring, just a lot of crap going on in here, but no doubt it was a lot of fun to build. And if I could ever get it sounding better, I would definitely design something with all those same functions that just sounded not like poopy, but that one just doesn't sound great. I think there's something up. There's something up with the power, where some or all of the parts are not getting enough power. That's all the non-polarized capacitors. So next I'll move on to the polarized capacitors after I get a little drink of water. Then after those I'm probably going to take a little break and go potty, because I do have to pee. Alright. So these should be easy, because it looks like they're all the same value. Yeah, they're all 10 microfarad. So basically, we just put them in, and the stripe goes on the negative terminal, which is the round hole. And they're also, one lead is longer. The longer lead is the positive lead. They're not always like that, but these ones are marked very clearly. I'm just going to double check that I'm putting in the right value. And these ones I usually don't bend the leads out, because if you just stuff them down in there, they'll stay. They kind of bend their own leads out. I think these are all 10 microfarad, which is going to make this easy. We're going to be done with these capacitors and all these little components pretty quickly. I'll just put all of them in. I'll just solder them all at once and we'll be done. That's pretty handy that they're all the same value, to be honest. Alright. Here we got lots of leads to solder, but it goes pretty quick when you get in a little rhythm. One more. I'm gonna see if some of the homies will come in here and hang out. Because why not? See if I can find a link that actually works. come through. Trim all my little leads. Looks like there's one I forgot to solder. That's okay. I'll come back to that one. In fact, we'll just do it right now. Just stabbed myself with the lead of that capacitor. That happens. Oh, see that? That one's sticking way up in the air. I don't want that, so I will, it's a pretty easy fix. I just kind of reheat the solder. Stick it back all the way down, and then trim the leads again. No biggie. Alright, the circuit's shaping up. Getting there. We got all the boring parts in. Now it's time to get exciting. Next up we're going to do diodes and transistors, and then we'll wire it all together, which is almost a whole second half to this whole thing. But before we do that, I'm going to go potty quick, and then we'll come back. All right. Back at it. Alright, so next we're going to move on to transistors and diodes. I'm going to go ahead and get some water again. So we'll do diodes first, since they're also quite low profile. Let's see. Let's try and only pull out the diodes here. Well, how about I just dump the whole bag out? So it looks like all these diodes are the same. And these are actually pretty fancy diodes. They are germanium diodes. See if it'll focus for me. Yeah, they're germanium diodes, so they're clear. And they're kind of an older technology that outside of guitar pedals aren't really used anymore. Nowadays, what are mostly used are silicon diodes, which I'll pull out one just to show the difference. So here we have, this is a pretty typical diode. This is called a 4148 or N4148, and they're silicon. These are more modern. These are what all circuits pretty much use nowadays, but they still make germanium ones for special circumstances like building pedals. And what diodes usually do in the context of a guitar pedal is they do what's called clipping. And what clipping is do a quick little doodle here. I'm gonna find my pen. So clipping, alright, let's say that's your guitar signal. Alright, strumming an E chord. And we'll say we'll put a line right about there. All right. So this axis right here, this is your volume in decibels. Okay? And everything above this gets clipped. That's why they call it clipping. And rather than this signal coming through clean, like these points here would all come through clean. But these X's, they're clipped, and that causes distortion. It crunches the signal, and it cuts off some of the frequencies, and that's what causes distortion. And now the Foxtone machine doesn't rely solely on clipping diodes. Something that would rely solely on clipping diodes is like this pedal. This half of it has clipping diodes, and that's actually what this little knob does, is it changes the clipping diodes, because different diodes will clip in different ways. And germanium diodes actually clip pretty harsh, which is why they kind of have that old, I think of like Led Zeppelin kind of sound, you know, very brown tone. But they're also a little bit quieter and sometimes a little glitchier, which is great when you're doing something like an octave fuzz, because that's the whole point. You know, it's supposed to be this big bluesy brown, angry, really cut off, almost gated kind of sound. And these germanium diodes are great for that. So, we'll get back to actually building the thing. Got our 4 diodes, and I think they're the exact same diode. You know, we might be missing a resistor, actually. Yeah, R12. It's not labeled as a resistor. Or I guess it kind of is. 220E. I've never seen that labeling before. R12 is a... Oh, that's the 220 ohm. That is the red, brown. See if I can find that one. It's gonna be this guy, isn't it? Uh-oh. Alright, gonna have to do some surgery again because I put something in the wrong spot. Which happens. Zoom back in on the subject here. And I will just kinda come through and see which one is in the wrong spot. Looking for red, brown. You know, I'm not seeing that. Red. Let's look at the full. See, it's a 220 ohm, right? So the full kind of color code is red, brown, black, brown. Yeah, here we go. Red, black, brown. Whew. I got a little scary there. We'll stick this guy in. Just solder him up really quick before we actually start on the diodes. Alright, disaster averted. We are good to go now. Alright, now to actually start on the diodes after 10 minutes of screwing around. So all these diodes look to be the exact same, and I'll check the bill of materials just to make sure. Because sometimes they can be different, but nope. These are 1N34A germanium diodes. So, the way diodes work is they are polarized, meaning one side will go in the positive, one side goes in the negative. That's notated by... Come on. You can do it. You can do it. Come on. You piece of shit, come on. Give me something. Alright, I think we can work with that. But you can see on this side, there's a stripe. Here it's kind of yellow and red, and this side doesn't have a stripe. So the stripe on the diode lines up with a stripe on the circuit board. And usually, looks like these actually aren't clipping diodes. Huh. But the stripe usually notates the negative side, which is called the cathode, I think. There's cathode and anode, and I'm pretty sure cathode is the negative side, and then anode is the positive side. But the negative side, or the cathode, will usually go to ground. But so that whole spiel I did earlier about clipping diodes doesn't really seem to apply here, because usually clipping diodes are set up in pairs. Where one will be facing this way and one will be facing that way. They'll be right next to each other. They might still be, they might just be set up differently as far as the layout of the circuit board goes, but I honestly don't know. I haven't looked at the schematic for this at all. I'm just kind of putting the kit together to test all my shit out and see what works and what don't. Alright, so we'll solder those two up. Germanium diodes are another component that I like to be a little careful with when I'm putting them in, just because they can be a little finicky and not quite as strong as some other components. I don't know, I have burned them out before, so I just like to be careful. Doesn't happen usually, but and the through holes on these guys are actually pretty large, which usually just means you gotta put a little extra solder in there. Alright. I got an itch. Oh. Alright. Once again, just clip the leads off. And then we'll put in the other two diodes. Lining up the stripe on the diode with the stripe on the board. That guy's in. And that guy's in. Alright, so that's all the diodes, at least on the actual board. Obviously we'll have LEDs, which are light emitting diodes, but those will come later and are somehow a little more convoluted than just regular diodes. Alright, and then we'll move on to transistors. Now, transistors look like that. I have 3 leads. Kind of like that. And they're usually marked with a Q on the circuit board. So we have Q1, 2, Q3, and Q4. And what transistors are is they're actually little amplifiers. And transistors, if we go back to our little drawing here, transistors, where'd my pen go? Here we go. So that's our transistor. Oh, that's our transistor right there. And they have 3 leads. You have the emitter, the base, and the collector. And the emitter always goes to ground. And then the base and the collector are kind of the power. I think collector usually comes from ground or from power, which is 9 volt. Someone just asked me to play a gig next Friday. Yeah, definitely not. Sorry, man. And then the base is what actually sends the signal through. So they're little amplifiers, and usually in something like this, a fuzz pedal like this, it amplifies the signal to the point of distorting it. Hold on, I gotta share this with the boys. This is fucking hilarious. Yeah, definitely, I'll play a fucking gig right now. No, absolutely not. Alright, so all these transistors are the same. They're 2N3904 transistors, which are pretty typical. And with these, you kind of got to bend the leads in a weird way to get them to fit. I'll do that quick, and then I'll bring them up so you can see. You kind of got to bend them out like that. And then they go, zoom in a little bit more. They go, you can see on the actual circuit board, there's kind of a half round part, and that goes with the rounded side of the transistor. They go in just like that. Stick them all the way down. And when I do transistors, I like to do them all at once, because when you're soldering transistors, they can be a little touchy too. I've definitely burnt out a transistor or two if you overheat them. So I'll just kind of go, when I solder them, I'll jump around. I'll solder one leg on one, and I'll move to the next, solder the next leg, solder that leg on another one, etc. Move on, and then just circle back around. That way I'm not overheating any parts, which I'm probably being a little too paranoid about, but I don't have any extra of these at the moment, so trying to replace that part right now would be a pain. I know where I have one. Actually, I have it in this big pedal, the one that I showed earlier. This side actually changes the clipping diodes, and you can use transistors as clipping diodes, which is a whole nother thing. But in there's some of these transistors, but I really don't feel like taking that apart just to build another pedal. So I do have some parts coming in from Mouser today that do have some of these, but once again, those are for something else that I'm very excited about that I would rather not just throw away for an entirely different pedal. So it just helps to be mindful of things and make sure you're soldering correctly, because if you aren't, you can kind of goof some stuff up. So just go ahead and solder all these. I'll start over here where y'all can't see. I'll start over here, just one like this transistor. Good to go. And then I'll come over to this one, do one like that one, come over to this one, do a leg of that one, and this one, and do a leg on that one. Then I'll come back, do a second leg on that one, rinse and repeat. And then the last leg on all three transistors. Alright, there's all the transistors in. I'll just trim all the leads. 3. Come in this way. 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Shiggy-diggy-diggy-diggy-doo. Oh, hi, Alex. Hey, Alex, you should tell the whole Marines to watch me. All of the Marines. All the Marines sleeping. Oh shit, I guess what time is it over there? It's like midnight over there, isn't it? Or is it later than that? 'Cause it's 13 hours or something? 14 hours? Midnight 30. 0030 over in JA Pan. Alright, I lost my train of thought. So yeah, that's the whole circuit board put together. It's pretty neat. See, there's a couple parts that aren't populated. Those are actually just jumpers. If I try to take my multimeter here. I like to do this just to test it, because even though they say jumper, and they look like they've already been jumpered, sometimes they aren't. So I'll take my multimeter, and I'll zoom out to show the multimeter too, because they're pretty cool little devices. Let's see. There we go. There's the multimeter. 2 leads, and when you touch them, it beeps. So just touch one to each pad. That's jumpered, that's jumpered, and that's jumpered. Cool. So those are all good to go. All right, next comes the fun part, which is kind of the whole back half of the build, which is where we wire everything together. So go ahead and pop open this enclosure. They give us some screws. Take the tape off. First thing I like to do is I'll put all the pots in. These are potentiometers, and how potentiometer works is it's just like a resistor, like this guy, except it's variable. So you can see here, maybe, it says B50K on there. That means it's a 50 kilo ohm resistor that you can vary the resistance of. So you turn it down, and it's going to have, it's actually going to have a lot more resistance, which is kind of counterintuitive, but as you turn it up, then it tops out at 50 kilo ohms, or thereabout. They're never perfect, and all pots are actually a little bit different, just because it's damn near impossible to get them all to be the exact same, but it doesn't make any difference sonically, really. And the B on there actually just refers to the type of taper in the actual the variability. So I think B, I don't remember what B is. I know A is a forward logarithmic taper, which means it kind of comes down in a logarithmic, well, I suppose I could draw a picture, couldn't I? So an A taper here we have resistance, and here we have, what's the other axis even called? We'll just call it X. Cool. So a logarithmic pot will kind of go like that. And then B might be linear. B might look like that. And then C is actually a reverse pot. So it will actually go like that. And C pots are useful in some situations, like on the Henry Hill. This tone knob is actually what's called a filter knob, and it works just like tone, but it works in reverse. So on something like a DS1, which is a modified DS1, but as you turn the tone up, it gets brighter. As you turn the tone down, it gets darker. Whereas this, as you turn it up, it actually gets darker. It's actually filtering off more high end. You turn it down and it gets brighter. It's not filtering off any high end. They work the same way, more or less. Sometimes the circuitry is a little bit different, depending on whether it's a high pass or a low pass filter. But the only thing that changes is the direction of the actual sweep of the pot. So what I'll do first is I'll put the pots in, and then I'm going to label them depending on what control they actually are. And then I will start to measure out wires that go from the circuit board to where the pot is. So something you have to do with pots too, not all of them, but on these ones, see there's a little tab there, that guy? You have to break that off. What it's used for normally is some things that people build will have little notches in the actual hole for the pot. That's just to keep it aligned. But we don't need that. We actually want to make these as low profile as possible. So we just break that notch off. It doesn't actually change anything. It's just an option if you want it. So I'm not showing at all what I am doing, am I? Let's see if I can adjust this camera angle. All right, we can zoom back in a little bit. So yeah, I'm just gonna install the pots here. You just go through the hole. Oops. Tighten them up, just finger tight for now. Later on I'll pull out a socket and tighten them all the way. But we have 3 pots here, and they're all B50K pots. So it doesn't really matter which one goes where. Sometimes you'll use a higher value or a lower value pot, depending on how much resistance you want it to have, just like you'd use a higher or lower value resistor to change the resistance you want. And some pedals actually don't have pots for typical controls. They will actually have the controls hardwired with set resistors. My favorite one is DoD used to make a pedal called the Death Metal, I think, in the 90s. It was this crazy sounding pedal, but it didn't have a distortion knob, even though it was this super high gain distortion pedal. And basically what they did is they took the value of the pot, turned it all the way up, and then just put in a resistor. And in the actual manual for the pedal, it said, there is no distortion knob. We just turned it up and ripped it off, which is awesome. And so DoD, they made some really cool pedals in the 90s that were wacky and just all kinds of fun. The dude who made those pedals was a guy named Chris Lamb, or Chris, David, Justin? I fucking forget his name. It was one of those names, but he had all kinds of crazy pedals. So yeah, those are all in. Just finger tight. And there we go. So now we have to start wiring things together. And I'll pull up the wiring diagram here that General Guitar Gadgets was nice enough to supply. And they also send you this little pack of wire, which is nice. They're really handy, and usually they send you more wire than you actually need, which is very cool. One thing I'm also going to do is label the pots, just so I'm not trying to figure out which one's which. You know, just looking at the diagram back and forth and back and forth can kind of get to be a pain in the ass. So I will just label them. This one here is volume. Label it with a V. We have tone, and this is sustain, or drive, or fuzz, or there are all kinds of things you can call it, but that's essentially what it is. So we can also see here on the circuit board, if I raise it up for you maybe, all these little pads at the top are actually labeled. They'll be labeled with things like S1, S3, S2, and that corresponds with the lugs on the actual potentiometer. And the lugs are labeled 3, 2, 1. They go backwards. If you're looking at them forward, it makes more sense. 1, 2, 3, but you know, this way. 3, 2, 1. So I will just pull out a color of wire. We'll start with green. Green's a fun color. This is a 22 gauge wire. Pretty thin stuff. And let's see, I need to find my scissors, wire cutter, and you can use a specialized cable stripper to strip all the cables off at the right length, and so you have enough actual cable exposed to solder it, but I just use a scissors and kind of score it and just pull it off with my thumbnail. That's probably not the best way, and it really tears out my thumb, but it's quicker, and I always just have shit luck with actual wire strippers. So, we will just get going, and I'll just measure out this pad. Goes to S1, measure it out to lug 1 on the sustain pot. Cut it off. And then I will just kind of score it like that on both sides. Strip it off, so now we have some exposed wire there. Same on the other side. And then I will put it through the hole on the board. Maybe zoom in a little bit. Put it through the hole on the board. Maybe. Sometimes you gotta twist these. Put it through the other side, actually, because that just looks a little neater. And then I will again let's see here. I'm doing a good job at showing what I'm doing. This part is the most finicky and also the most time consuming. It can be a real pain in the ass sometimes, but again, get it all clamped up. The wire held in place, just like that, and then I'll come in and solder it. Bada boom. Alright, and that's one wire. We only need to do that a billion more times. So, we'll do the same thing, this time with S3. And I'll use a different color just to make it easier when I'm wiring everything together in the end. So here, this goes to lug 3 on the sustain pot. I'll measure it out, clip it off with a little bit of excess. Oh, that's why I do a little bit of excess, because sometimes I will just cut right through the wire on accident. Why do they call it oven when you in the cold food, of out hot eat the food? Alright. And same deal. Just feed it through the board. Attempt to feed it through the board. and solder it. Alright, next one, and I'll pick a third color here. I can zoom out a little bit. There we go, there we go. And this goes to lug 2 on the sustain pot. Just like that, measure it out, cut it off. Strip back the insulation. Feed it through. There's not a lot to talk about at this point in time, is there? That's alright. When we actually start wiring components together, there'll be a lot to talk about. I'm gonna drink some water here. My throat's getting dry. Some good water. Vape a little. All right. Now, next one goes to the tone pot. I'll just bend these wires out of the way. Tone pot. We'll go back to green. This goes to lug 3 on the tone pot. It's a short little wire. Strip the insulation off. Feed it through. Get it all clamped up and solder it. Same thing, we'll go back to purple. This goes to lug 1 on the tone pot. Just measure it out, clip it, strip it. Accidentally cut some off, it's okay. That's why I leave extra. Sometimes it's hard to strip these little ones. There we go. I didn't strip nearly enough. I keep looking up at the camera to make sure I'm actually in the frame. That's just kind of throwing me off. There we go. There's some interesting noises coming from upstairs. Sounds like someone's dragging a gigantic piece of rubber across the ground. But there is a child upstairs and they tend to do weird things. Well, god dang it, just go in. That looks a little messy, but it's on the underside. No one will ever see it. Actually, no one will ever see it because I'm probably not going to give this pedal away. Because I really like the sound of a Foxtone machine, and I would like to use this. I don't know what for, but if I ever pick up guitar, it'll come in handy. Which I do want to do. I'm actually looking into getting a guitar because I like my bass 6, but it's just not a guitar. You know, it's close, but not quite. Alright. And this one, plug 2 on the tone pot. Again, clip it. And strip it. Maybe. I think I ordered a big breadboard kit online, and I think it came with one of those little plastic wire strippers, and they actually have like a razor blade on them, and that just looks a lot easier to use. So I will likely use that when it shows up. And put that actually somewhat in the frame. Alright, last one. We'll go back to green. This goes to lug 3 on the volume pot. Just measure it out. Doesn't really matter when they're that short, because they're always going to be a little bit too long when they're that short, if that makes sense. Alright. That's all those ones that go to the potentiometers. Now we have to wire a couple other ones. Let's see, I think one goes to an LED. Just looking at the wiring diagram. Nope, doesn't go to an LED. Looks like those actually go to the 2 foot switches. So, next thing I'm actually going to do is go ahead and wire up those foot switches. Or not wire them up, but there's some kind of preparation wiring you have to do with a foot switch. I also just want to talk about foot switches because I think they're cool. So, this is what's called a triple pole double throw switch. And it's triple pole because it has, 3 poles. It's a 3x3 grid, but has 3 poles, as they call them, and it's a double throw because it has 2 throws. It has on and off. And when you turn it on, it goes to 1 pole. When it goes to 1 throw, which is one of the poles, turn it off, it's the other throw that goes to the other poles. And then usually the 3rd pole is ground or something like that. So, we have to wire in some little jumpers that just kind of carry the signal around the switch, so when you turn it on or turn it off, it will bypass certain parts. And so since we have 2 of them, we have to do it twice. And when I wire up a switch, usually I'll put it in the little hole for my solder thing. Oh, I'm actually looking at the wiring diagram. We actually only have to do this for one of them, which is convenient. So I'll pull out some black wire to do this here. If I can find which one's black. There we go. I like to use black wire for this. Alright. First little jump we have to make is from this lug to this lug. So I just cut off the tiniest little bit of wire. And strip it. There we go. Alright. And then with these little guys, I will just bend them basically right in half. So they look kind of like that. And I'll twist up the wires to make it nice and neat. They just go right through the little eyes in the lugs. Just like that. And I usually take a screwdriver, actually flip them upwards, the extra wire, just so they're out of the way. Because I have more than once shorted things out just within the foot switch. I might actually do. Just so this isn't moving around, I can film it better. I'm gonna go ahead and put the switches in their holes. Just solder that wire real quick. At least attempt to. And then I'll just check to make sure there's actually decent enough connection there. And then I'll take some little wire cutters. And anything extra just comes right off. And then now the next jump that we have to make goes from this lug down to this lug. And I will do that with black wire as well. And when I measure this, I just kind of butt it up against there. I attempt to at least. And just measure it right about there. I like to do this one as exact as I can in length, just because I'm going to be soldering a lot of things around it. And I don't want to have to work around all that extra wire if I don't have to. So again, just gonna strip the wire. And I'll actually do this one lug at a time. And wrap it around, do the other one. Just like that. So that's that one. And where'd I put the other foot switch? Take the farmer wrench and just tighten this up a little bit, because these ones like to move for some reason. I think it's because there's not as much metal to metal contact as with a pot. Here's the other foot switch. We'll put that guy in so we can start measuring out wires and wiring things together. Just like that. Not super tight, but just so they're steady. All right. Put our circuit board back in. Now I'm gonna have to zoom out a little bit for this part. Now we start wiring, or I guess measuring and adding wires to the circuit board that are gonna go down to here. And looks like there's 1, 2, 3, 4 of them. 4. All right, so we'll start over here with what's labeled O2 or D2. And D2 is actually going to go, if I trace this all the way around, it's going to go right here to this lug on switch 2. We'll just pick a color. We'll go blue. Why not? So D2. Just measure it. Be about there. Give myself a little extra. And I'm actually going to wire this so it goes this way towards the switch, so it'll go under the board. just because that looks neater. I always want things to look good, because if they look good, they usually work better. I don't know if that's actually true, but looks like we are going to have to clamp that. Sometimes the wire is just kind of situates itself in just the right way where you don't have to clamp it up in the helping hands. But that seems to not be the case with this one. When I'm putting wires onto the board, I kind of overdo it on the solder on purpose. Alright, next one we gotta do 01, which that looks like it's going to go to this point. Oh wait. Yeah, goes to the next lug down. The one on the bottom right here. So, pick a color. Let's do white. They always send you a bunch of solder, which I don't really see the point of. Because if you're doing this, you probably already have solder. But I'm sure there's someone out there who appreciates it. And again, I'll just kind of measure it. Give myself a little bit of extra. Strip the wire. Feed it through. Bend it out. Solder it. Alright. So another wire we gotta run is for the power. And I always use a red wire for power. Just kind of helps me to know what I need to do. And I'll usually run a fair bit of extra wire for power. That just goes out to the top of the case where the power jack will go. So we'll call it like there. And we'll cut it. Just like with the rest of them. Feed it through. Bring in a little helper to hold that wire. Alright, next wire, this one's going to go to the switch. It's for the input. That's actually going to go all the way from here all the way down to here, which is the in on that switch. So for in, we'll go ahead and use green. And we'll say like that. That's probably enough. Cut it off again. Strip it. Maybe actually strip it this time. There we go. And this side. Feed it through, or at least try. Oops, this wire's actually gotta go down this way. Solder it real quick. There we go. Alright, now we just have to run 2 ground wires. One will go to ground on the input jack, and then one will go to ground on this switch here, which is the middle pole right here is always ground on both of these. For ground, it's good to just always use black wire. Let's measure out about that much. Strip the wire, strip the wire. Alright, I'm actually gonna take a drink of water, because my throat is mighty dry. Alright. Take a little hit of my vape. Is anyone still watching? Looks like the boys are still watching. It says so. It's nice that they came to hang out. One last ground wire. That's gonna go to that middle lug on the switch there. And call that good. It's fairly important to get these wires maybe not as short as possible, but short as you can, you know, within reason, because every little wire is going to act like an antenna, and that's going to create more noise, and we just don't need any extra noise in a pedal, especially one like this where it's going to be mighty noisy just by nature of the pedal and the way it works. that's all the wires connected to the circuit board now. Next thing we have to do is there are some wires that are actually going to go from the pots up here down to the switches. So I'll zoom out a little bit so we can watch that magic happen. Let's see. By some wires, I mean a single wire, looks like. Yep, which is pretty normal. And that's the output that's going to come out of the switch from here is going to go up into lug 2 of the volume pot. This one here. And then after the pot affects the resistance, the output's actually going to be from here, and that's what's going to go into... Oh, sorry, no. The output's actually going to come out of lug 3 back into the switch, and then from the switch. Or no, what am I thinking? I got it all backwards. It's actually going to go into lug 3 from the circuit board, out of lug 2 into the switch, and then from the switch out into the output jack. So let's wire that up. We'll do purple. That looks about good. Maybe a little extra. There we go. Again, clip this one off. Strip it. And I will run it through the pot first. And again, when I'm soldering pots, just like on the switches, I will put some of the lead through and then just kind of flip it up. I'm going to put a little more solder just to make sure we have a good solid connection there. Oh. See, I just goofed it. Sometimes the lugs on these pots take a while to cool down, so the solder will stay hot. And you'll move the wire and pull it right out. There we go. Now this one, since the LED is going to go right there, I'm going to bend this wire so it stays out of the way of the LED. And I might actually cut the wire a little too short, so we'll try and give it a little extra length just by heating it up. Just putting just the tip of the wire into there. Just like that. And then I'll actually go in through the top of the lug. I'll use a little arm here to hold the wire where I want it. Maybe not. This part is always so finicky, but it's kind of the most fun because it's the most time consuming. There we go. And I'll just hope it stays when I come in with the soldering iron. Put it in place. Alright, and then now I'll kind of bend it into the shape that I want. just like that. Now before I'm done, I'm probably going to try and tape down all the wires that are going to kind of run against the top of this. Just makes it neater. I think we can do LEDs now. Now the LEDs they send are these. They're red and green. And, well, these are totally fine LEDs. There's nothing wrong with them. I like some of the ones that I have because they're actually clear. I'll pull some out here. Here we go. Let's see, should we do blue or green? I'm gonna do one orange and then one of another color. Think about what color I want to paint this pedal. I think green, because I have some yellow knobs that I might put on here. Actually no. I'm gonna put yellow knobs on the other pedal that I'm gonna build tomorrow. I think, because this one, I suppose it doesn't really matter, does it? Thinking. Yeah, you know what? I'll put yellow knobs on this one, and we'll paint it green maybe. And then we'll do one orange LED, and we will do one green. Parts plays away. I'm actually have to pull those back out because I need some resistors. On the diagram that General Guitar Gadget sent, it's saying to use a 1K ohm resistor. I don't like that. I think they did that because these LEDs that they send don't emit quite as much as these ones that I have. These are pretty fucking powerful. I can show you actually. If I just if I plug this guy in really quick. You can see just how bright those are. And that's why I like the LEDs that I'm going to use, just because they're crazy bright. So we'll go for a little bit higher value resistor. Again, I just have some sitting around. Usually you don't want to go higher than like 5K. Usually 2 to 5 is good. We'll go ahead and use some 2.2s that I have. Which are these guys. And they will do us just fine. Bump the microphone. So we'll do the orange LED as the main power, and we'll do the green one as the other one. So pop in, they send you these little guys, they're just little bezels. The LEDs just snap into there so they look a little prettier once they're in the actual pedal. And they're nice and cheap too. I have like 100 of them. I got for like $1. Thank you, Simon, for sending that beautiful picture of Matthew Lillard. So LEDs are polarized just like all diodes, and one's positive, one's negative. anode and cathode, and the anode is always going to be the longer of the two leads. You can kind of see how can I show this off here? One lead is longer. That's going to be your positive, and that's going to go to 9-volt power, and that's going to have a resistor in between it and the power. So usually how I do this, I'll go ahead and tighten this up here. I'll zoom in a little bit. I'll clamp the LED into one little helper. I'll clamp the resistor into another. Just kind of touch them together. Get them just about as close as possible. Sometimes it takes a little goofing around with it. That looks about good. Take my soldering iron, heat it up, just flow solder all along the length of it. Just like that. Let me dig out. That's nice and out of focus, isn't it? There we go. I'll dig out some heat shrink. We'll go with this size right here, which is 3/32 diameter. And just kind of put some along the whole length of it. Just like that. Take my lighter, just shrink it up. The reason you need to put a resistor on there is that if you don't, it'll just fry the LED. 9 volts is a little too much for an LED. So you put the resistor there so it doesn't quite give it the full 9 volts. I also like to, after I do this, I'll test them quick just by taking my 9-volt power supply here. Outside is positive, inside is negative. So I'll stick it right in, and then just kind of bend the resistor lead around. And if I did it right, it'll come on. And we'll do the same with this guy here. Again, just flow some solder into there. Bada boom. Heat shrink over the resistor onto there. And just with the lighter. You gotta be a little careful with this because you can absolutely burn the heat shrink. If you burn the heat shrink, it usually doesn't come off very easily. So, once again, I will test it just to make sure I wired it up correctly. Huh. Now there's a couple reasons why that might happen. Let's try. Oh yeah, I just wired it backwards, which isn't a huge deal. I just have to remember that the green LED has the resistor on the negative instead of on the positive. It doesn't make a difference as long as you have a resistor somewhere in there. That'll actually help me out a little bit, I think, as far as being able to tell which LED is which. Yeah, so that's good. I'm gonna keep my heat shrink out because I'm gonna have to use that again in just a moment. Alright, come back with our pedal. And this, zoom out a little bit. Kind of losing my train of thought here. So one leg of the LED, the negative, is going to have to go, where do they want me to put this? Goes right here to this point on the foot switch, and the negative lead of the other LED will go to this point on the foot switch, on the other foot switch. So I think we said we wanted this one to be orange, so I'll just test it again. Alright, so that one's green. So we'll get the other one. Alright. Get the other one, and I'll just stick it into place right now. I'll have to pull it back out in a second, but just shove them into place like that. So I know this positive, I think they just want me to wire it straight to positive. Yep. So we'll just stick it out the little hole at the top. We know this is going to have to go to negative. We'll use black wire again and just measure out. Only use about that much. And on one side I'm actually going to strip back quite a bit of insulation. A lot more than I maybe normally would. Just so I can get more contact with the actual LED. Pop the LED out. Get it all clamped up. That looks good. We'll just touch it with some solder. There we go. And I'm actually going to use a smaller size of heat shrink this time. Boom, just like that. So that's one LED. And one more time. I just always like to test these because I can have and will put them in backwards and things like that. So, all right, one more time. Put it back in there. These just friction fit in there. These kind of gotta shove them down. And they go in. Bring our wire around to the foot switch. Sometimes it helps if I turn the pedal around so I can get better access to different things. I'm sure this is really hard to see on the camera. Alright, so get it through the lug of the foot switch. Just like that. And I bend it up. Same deal as before. Soldered in place. And now we'll do our other LED. If I remember right, I put this one together backwards. Yep. So this one might be a little more complicated to wire together. Since we're actually going to have to run 2 wires. I'm going to spin this around here just with my pliers. No, that's not going to work. Pop it out. I'm doing a pretty bad job at filming all this, aren't I? Again, just going to take some black wire, measure out how much exactly we need. This negative lead's going to go to, whoa, I'm not anywhere in the frame. This negative lead's going to go to right there. It's just a short little jump with some wire. Just like, that much. That'll do it. Might be too short now. Pull this LED out one more time. Just get them right next to each other. Alright, alright. And then another little piece of heat shrink. Just like that. Hit it with the heat to do the shrink. Speaking of shrink, hope everyone's doing well. Stick the LED. Ouch, that lead is still plenty hot. I'm just grabbing it. I seen him, and I grabbed him. And just run this around to the foot switch. I'll flip the lead up, just like that. And solder it. I left a little extra. Just pop it off. What I might do actually, since these two are quite close together, I might wire them together and then wire a lead to go out to power. We'll just do that. Just to make this a little bit easier. Yeah, we'll do that. So I'll just cut off a little bit of wire, enough just to get out to the jack. And then what I'll actually do is just right next to the resistor here, just kind of wrap it around. I'll take the heat shrink and it'll go hopefully go all the way down. No, you know, that's not gonna work. That's not a very good solution. So we'll just do it the right way. And we'll just run wires to go out. That's the nice way to do things. Same deal. Just run some solder there. Now we can use a little piece of heat shrink, which will just look a little nicer. run that out. What I'm actually gonna do is just to test this. Let's see, what do I have? Here we go. Will that work? No. I just want to test. Since that one is wired backwards, I have a feeling it's not actually going to work in the context of the whole circuit. So what I should be able to do is just get kind of a loose piece of wire. Just like this. And this will just be kind of a ground wire for the time being. And I'll run it through the middle lug down there, which is where the ground goes. Take my power jack, and I'll just plug it in. And then just kind of cheapo wire it up. Without actually soldering anything. And that'll just let me test if everything's working. Yep. And flip this switch. Oh, that's right. I have the ground set up wrong. Yep, cool. Alright, so that's easy enough. Doesn't really matter that they're put together backwards. I didn't think it would matter, but I'd much rather take 10 seconds to test it now than take 20 minutes to rebuild the whole thing when I find out they don't work later. So, and then I'll just kind of scrunch these wires down a bit so they're nice and out of the way, so we can get to the next part, which is going to be to wire everything together. I'm just going to double check to see if there's anything else I have to run beforehand. I don't think so. So now what I'm going to do is I'm going to get my circuit board back out, make sure all the wires are running where I want them to, and then I'm going to get these. These are the little feet that the motherboard are going to stand on. I'll just put them in. They just kind of go through these big holes here. Sometimes they're a little hard to get in just because you don't want to crush any components or break anything, but yeah, alright, that all looks good. I'll bend these wires up down here, bend these ones up here, just like that, and these just have adhesive on the back. I'll take that off. Stick the circuit board right where I want it, right in the middle. Just like that. Cool. It's taking shape. We're almost there. take a little water break again. Plug in my phone too, since it's just sitting here. Alright, so let's go ahead and put all these wires into the potentiometers. So we know this goes to sustain 1, and looks like we already have a problem. That happens. It's just not quite long enough. Or, no, yeah it is. My bad. I had the pots kind of mixed up, but we'll go ahead and zoom in some more here. So this wire is going to go to lug 1 on the sustain pot. So I'll bend it out just a little bit, just give me a hook. That makes it that much easier to just get it into the pot. Throw some heat on and just flow it with solder. Just like that. Here's the one where I goofed up. It's just not long enough. This wire here, that is very out of focus. This wire here needs to go all the way over here. It's just not long enough. It happens. So what I'm gonna do is I'll just, what's the word here? Just join on a little extra piece. Splice, that's the word I was looking for. I'm going to splice on a little extra piece. That's not a very good joint. Just have to hold it. I'll just take a tiny little piece of heat shrink. Just like that much. Heat the shrink and shrink the heat. run it over to the point on the pot. All right, this goes to sounds like it might be getting a visitor. There we go. I'll just kind of lay those wires flat. Maybe tuck them underneath the circuit board a little bit. Alright, next we gotta run this wire to lug 3 on the tone pot. This one, we'll do this one next, goes to lug 2 on the tone pot. Same thing. I just put a little hook in the wire, run it through, just like that. Lay the wire down flat. This last one, go to lug 1 on the tone pot. This is a little tedious here. All right. And this last one is going to go to lug 3 on the volume pot. Put my little hook in the wire. This camera just does not like to focus, does it? It's alright. I paid like 30 bucks for it on eBay. And they're like 150 brand new. So... Alright, so there's everything wired up to the pots. I'm going to go ahead and run these two things for the power out the top. So we can cross that bridge when we come to it. Alright, now we got to do the wires that come out from the bottom of the circuit board and go into the foot switches, so... Excuse me. Alright, so I made a goof here. This wire is supposed to go all the way over there, so I'm gonna have to pull the circuit board off of its little feet, which isn't too hard. It's a little annoying though. You kind of have to, these little feet, you have to squeeze them together. Y'all are not going to be able to see this at all. Let's see. How am I going to do this? There we go. Once you get one side up, it's pretty easy to get the other one up. We have a transistor in the way. There we go. Just like that. And then we'll just make sure to run this wire over to this corner. Push the board back down. I still don't think it's gonna reach. Not sure how I managed to do that. That's alright. We'll just splice some wire onto it. So close, but so far. Get our green wire out. We'll just measure enough to get it there. Hearing some kitty cat noises outside my door. I think I might be getting a toolbox inspection here pretty soon. Doing this always makes me suck in my gut for some reason. So every once in a while I just have to take a deep breath and remind myself that it is okay to breathe when I'm doing this type of stuff. Heat shrink's being a little difficult. All right. Boom. All right. I burnt that one a little bit. You can smell it. All right. So now our input's gonna go to this lug, the middle left lug on the foot switch. Kind of amazed at how simple this circuit actually is in comparison to some that are a lot more convoluted, like this one that I keep showing off. The circuit's actually got a lot going on for it just being a pretty simple, like, op-amp distortion. But usually simple circuits sound a lot better, just to my ears at least. Like my tone bender clone that I built. It's a very simple circuit. It's literally just 3 transistors in and out. Boom. It was such an easy circuit that I was actually able to redesign it, and I'm getting some prototypes made. But there's just not a lot going on, which is in no way a bad thing. So now this blue wire that comes from O1 is going to go into this point on the foot switch. I have a layer there. This point on the foot switch. And again, I cut the wire too short. Alright, what I think happened is when I was measuring all these wires, I had the circuit board a little further down, kind of against the foot switches. Then when I actually put it down, I moved it up a little bit too much. What we might be able to do, though, is I'm just gonna reheat the solder up here. Just pull it out ever so slightly. Oh wait, no, I think we're okay, because I think I actually... I'm gonna have to take this out of... Oh, never mind. Nope, we're good, because O1... Which, now I know why they're labeled O. It's for the octave foot switch. O1 is actually a white wire, which is this one, and it's plenty long to get us to the foot switch down here, where it needs to go. This one is still going to be just a little short, but we can make it work. what I'm actually going to do is I'm going to heat up the lug, put some solder into it, and then when I get the wire to actually touch down there, I'll just heat the lug back up. And the wire should join right up to it. It's a pretty finicky connection, isn't it? Woo! Ouch, that's hot, but I gotta hold it. Alright. So that worked out. So that's pretty much everything wired up, except for this ground. Ground will just go to this middle lug right in the center. What I'm actually going to do, I'm going to do this one and another one at the same time, because we have to ground the two foot switches together. And you just run, all you do is just run a cable or a wire from here over to there. So I'll just do those at the same time, so that way I don't have to reheat the joint and try and put it through and knock something out, and it's a whole mess. Not worth the hassle when we can just do them at the same time. So again, I'm using black wire. Smells like a kitty just took a poopy, 'cause I can smell it. I'm gonna go ahead and actually flip all these little legs up. A fair amount of solder. Alright, we're on the home stretch here. Into that foot switch, just like it is on the other side, right in the center. And basically now all we have to do is wire up our input-output jacks. So for input and output, you actually use two different jacks. For input, you use a stereo one, and output, you use a mono. And the reason you use a stereo is so that you can wire up a battery clip. And also use a stereo so that way when you plug in a cable, then it will start to draw from the battery, and when you unplug it, it won't. Just so that way your battery doesn't run out while it's sitting on your shelf. Alright, take another little water break. Let's actually wire up power first. And there's quite a few ways to do this. What I like to do, here's what the jack looks like. Something like that. And then on the back, it has three legs, three little lugs. The one that's kind of bent at a 90, that's always your negative. Or rather, it's the center pin. but we wire it up as negative, and the other two are both positive 9 volt. So, and it has a little nut on the outside. What I do is I just take the nut off. And I just feed all the wires through the nut first, because it's a lot easier to solder all these leads on these small little power jacks outside of the case. And since the nut goes on the inside, you have to feed them through first, but it's easy enough. And if I were to put a battery clip in, I'd do it right now. I don't think I will, just because I don't use batteries and I don't intend on giving this pedal away at all. Alright, vape my noggin off quick. And holding these power jacks is difficult sometimes in the helping hands, just because there's not a good flat surface. So I'll take, you see how there's little rubber tips on these ones? I'll take them off of one, and then you can just hold the power jack kind of like that. So we'll go ahead and wire up the negative first, mostly because it's the shortest. I just feed it through. Twist the wire a little bit. Move the other wires out of the way. Solder it up. Now we'll do all the positives. This can get a little finicky too, especially since we're going to put 3 wires into one lug. Well, maybe. What's the best solution here? Because this is kind of a pain. I think what I will do is actually go with what I said I was going to do earlier. And just, we'll splice. It's kind of like that. that. Just wrapping the wires around the lead of this resistor. Doesn't really make a difference functionally. I just think it looks neater and it's a little more proper to do it the other way, but that's okay. And then this will feed through there. Oops, where'd the nut go? Let's feed this leg of the resistor through the lug on the jack. Solder it. There's a little extra lead that I'll just come in here and trim off. Alright, and then I just pull all these back. And tighten up the nut. I hate these nuts. They cross thread themselves every time, most of the time. I just tighten it down. Now let's take my pliers. Really try to tighten it all the way. Alright, so the pedal should actually turn on now if I plug it in. Maybe not. Oh, I know why, actually. Because I don't think... Yep, my bad. This black wire here doesn't actually go to the power jack. I just kind of did that backwards. We'll just pull it out. A different wire will go in there in just a moment. Alright, where'd my input jack go? Take all the little bits off of here. And put the output jack in. Alright, so this jack, the input jack, is what's called a TRS, or a stereo. That's because TRS stands for tip ring sleeve. So if we look at a regular 1/4" jack, here we have the tip, and this is the sleeve. The sleeve is always ground, and the tip is your actual hot signal, where the sound actually goes through. And in the context of this when we're using a stereo jack as a switch, more or less, to switch the power to the battery on and off. The the ring and the sleeve both will go to ground. And so this is the ground from the board, and that will go to the sleeve. And the sleeve is always the middle lug here. So it's just as easy as sticking the wire through. Heat it up. And just touching some solder to it. Just like that. Okay, so now we have to wire our hot signal to the input, and that's going to go right down here on the foot switch, where we kind of have that jumper that goes across. Goes into the same one. So I'll go ahead and use yellow wire for that. I'll just feed it through right now, just to help me measure. And cut it off right about there. And I actually left a little bit, you're not going to be able to see this, but I left a little bit of space underneath the jumper there. Yeah, you can't see it, but I left a little space underneath the jumper wire so I can feed this through. Maybe not enough space though. It's kind of hard. That's alright. Don't even have to bother with it. Basically, I'll just heat this point back up. That's not a good connection. Ooh. I'll just make some space in the actual lug just by pushing up on that wire. There we go. That's a little messy, but it'll work. I'm gonna put some extra solder in there, just to be safe. Just like that. And that goes to the tip, which is this one over here. And now the sleeve, or the ring rather, is what would go to the battery connector. Should we put a battery connector in? Why not? I have one right here. I can put one in. It doesn't take all that long. It's pretty easy. Positive and negative. The negative goes on the ring. Man, these helping hands, they're nice, because doing this stuff would be impossible without them, but helping is an interesting word to describe said hands. Then the positive from the battery clip goes into that extra little lug on the power jack. Alright, battery clip's wired up. I'll just tuck it out of the way here. So now we need to run some ground wires on the jacks. One's actually going to go from the volume pot, lug 1 of the volume pot, onto there. The sleeve. So we'll just measure that to go right about there. Strip the wire. It can be kind of hard to solder to a lug on a pot. That's kind of underneath everything and out of the way. So what I'll do is I'll put actually a full-on like fish hook in the wire. I don't know if you could see that. Yeah, like that. And then I'll just let it focus again. Slow to the draw, but I'll just hook it down into there. And then use a little helping hands. We'll use this side actually to just hold it just so I can come in quick with the soldering iron, some solder, and just touch it up just like that. Then I'll bend the wire, put it through the lug on the output jack, but I'm not going to solder it yet because there's a couple other wires, or one more wire we have to run into there. We have to make sure these are grounded together, so just from the sleeve of one to the sleeve of another. With a black wire. Feed it through. Just like that. Nice big fat glob of solder on there. And that will run right here. We also need to prep one more wire. That'll go from the negative terminal on the jack, again, to that middle point there. So we'll just measure that. Be right about there. Cut it. Strip the wire. And then I'll just, since there's already solder in the lug on the jack where I goofed up earlier, I'll just kind of heat the solder back up and stick the wire back in there. And these two I'll just twist together just to make it easier to work with both of them. And then this time I'll actually do it. Heat the solder back up. Sometimes it takes a second because it's a lot of metal to heat up. Maybe we'll come in from the top, huh? Just like that. Not even in the shot. Then I'll just run some more solder into it to make sure the connection goes all the way up the wires. Alright, and I think we're done. Let's see if it'll turn on now. Nada. Alright. Let's see. Well, that's right. I forgot we wired up a stereo jack. Still nothing. That's alright. We're not quite done yet. Oh my god. And these jacks are brand new. They are tight. And now we just have to wire up the output. Hopefully it'll work once I do that. It's a little scary when it just doesn't work. We'll use white. Why not? So, from this one, I'll go up to the jack there. strip the wire, maybe. Make a little fish hook, get it in there. Y'all cannot see what I'm doing. By y'all, I mean Alex, if he's even watching. Just onto the tip of the output jack. All right, now, will it turn on? Nothing. So now we have to find out why. This is the fun part here, is when things don't work. If it's not turning on at all, I'm guessing something's just not getting power. But I'll just look over my wiring really quick and see what, if anything, would be shorting out or just not connected properly. This whole mess right here with the power jack is a little iffy to me, so we're just gonna, something worth testing. If it doesn't turn on, normally is we put a battery in there. See if it'll turn on with a battery. And it will. So that answers my question. There is just something wrong with this, where I have the 9-volt connected. So, let's go ahead and desolder this little mess that I've made here. We'll just try to do it the right way. Let's just, let's try this here. Just gonna take a red wire and just splice these two together, and we'll see if it powers up then. Let's see, we don't really need all that much. Just like that should do it. This is not going to be easy. strip off a little more insulation and then just try to wrap it around. There we go. That's gonna work. Some nice big blobs of solder. I'll just like take my pliers and squish all this together. We're gonna need a pretty decent sized piece of heat shrink to cover up that gnarly mess that I've made. Yeah, that'll work. We'll just cut this in half. Feed it onto there. Just like that. Shrink the heat and heat the shrink. Just really quickly, I'm just gonna plug it all in and then just touch that to the terminal I want to use. If I touch it to that one, it'll work. If I touch it to this one, it won't. I think I have a bad jack, boys. That seems to be the case. Wait, no I don't. I just have things wired up backwards. Trying to do this with a camera and trying to talk while I'm doing it is a pain in the ass. But it's alright. I just have to desolder from the battery clip. I'm actually going to clean out the positive lug that I want to use just with a solder sucker. I did not do it. Didn't quite do it. Clean off my soldering iron. There's a lot of extra solder on there. There we go. I'm gonna get some heat shrink to put over here. Yes. Dad texted me, wanna know if I can work tomorrow. You frickin' betcha. Just a big old thing of solder there. Alright, now, look at that. We'll wire up, or rewire, I guess, the battery clip. And there we go. See if the battery clip works. You bet. You bet your sweet boopy. Alright. So now the fun part. We get to try it out. Hopefully it works. Zoom out. Got the base 6 plugged in. Plug it into power. I like to start with everything off and everything down. Is that being heard? Sure is. Alright. Well, it works in bypass. That's the first step. Alright, now, let's see. I think this one's the on. It works. It's noisy though. Alright, now let's try this side. Well, I say that works. I think it sounds pretty good. I like that. I've wanted one of these circuits for a long time, and it's cool to finally have one. The octave effect is really awesome. Panic chords. That sounds pretty cool. Let's hear it with some humbuckers. Some bass humbuckers. This fucking mic stand is driving me over the edge. Here we've got the Fender Telecaster bass. It's got 2 humbuckers in it. So I can find a pick. I like that a lot. Forgot how to play that riff. There we go. That's just a lot of sound. So many notes in one sound. It's cool. I like that tone a lot. I like how it just does not like chords. Well, that's pretty awesome. I'm surprised it came out that well and went together that quickly. Let's see how long have I been live here? Yeah, 5 hours. That sounds about right. The one I do tomorrow is gonna be a lot faster. Yeah, the one tomorrow is gonna be a lot faster just because I already have a lot of parts labeled and everything's already set up, so it's not gonna be hours and hours and hours of me just looking up what part goes where. So that'll be easier, but cool. I think I'm gonna get some paint for it and paint it up. Cool. Well, I'm gonna end the stream. I don't know if you're still watching, Alex, but thank you. Let me know what you think. If there's anything I can do to change levels or change quality or whatever would work best. But yeah,